Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review angles and triangles. This is going to become useful when we do similar triangles. So we're going to start by reviewing angles and parallel lines. So there's three that you need to know: co-interior, alternate angles, and corresponding angles. So these three require parallel lines. If you have a pair of parallel lines as indicated by the arrows, then co-interior angles are supplementary. That means they add to 180. So like if this angle was 120, this would be 60. If this angle was 100, this would be 80, and so on. Co-interior angles make a C shape. It can be a back to front C. So this angle here and this angle here would also be co-interior. What comes up more often with similar triangles though are alternate and corresponding angles. So alternate angles are equal if the lines are parallel. Alternate angles are closed by a Z shape. Again, it can be a back to front Z. So these two angles here are alternate. They must be equal. And if we have a back to front Z, this angle here and this angle here, they are alternate and must be equal. Corresponding angles are also equal. They make an F shape. So this angle here and this angle here, they're equal because they're corresponding. But the F shape can be back to front or it can be upside down. So this angle here and this angle here, they are corresponding. These two angles here, this one and this one, they would be equal. They are corresponding. So whereas co-interior, alternate, and corresponding angles require parallel lines to be supplementary or equal, vertically opposite angles are equal regardless of whether or not the lines are parallel. So vertically opposite angles make an X shape. So these two are vertically opposite, as are these two. These two green ones are vertically opposite, as are these two. It's very clear why. The blue and the green must add to 180 because the angles in a straight line are 180. These two are supplementary. But these two are supplementary and must add to 180. So the only way this and this can add to 180 at the same time these two add to 180 is if those two are equal. Similarly, these two angles here add to 180. These two angles here add to 180. Only way that's possible is if these two are equal. Alright, let's now look at applying this in triangles. So in this diagram we have one smaller and one larger triangle. So let's figure out the unknown angles here. So we have a pair of parallel lines, and notice that we have an F shape. Yes, it is an upside down F, but that's okay. This angle here and this angle here are corresponding, and we have parallel lines, so they must be equal. So this angle here must be 65 degrees. Similarly, this angle here and this angle here must be 65 degrees. They are both equal because they are corresponding and we have parallel lines. So what about this angle here? Well, remember that the angles inside any triangle add to 180. 65 plus 65 is 130. You need 50 degrees more to get to 180. So that angle there is 50 degrees. So each of these triangles, smaller and larger, is an acute angled isosceles. They are acute angled because each of their angles is acute, below 90 degrees, and it's isosceles because it has two equal angles. So it turns out that in any triangle, the number of equal angles is the number of equal sides. If a triangle has two equal angles, it must have two equal sides. So the two equal sides are these ones here and here, and similarly these two sides must be equal. It's always the legs of an isosceles triangle that are equal. So you know where the legs are because they are the ones opposite the equal angles. So this is an acute angled isosceles triangle. Let's now look at these two triangles here and figure out the unknown angles. So this one we can figure out pretty easily. 54 plus 76 is 130, so again we need 50 to get to 180. The angles inside any triangle add to 180. So whenever you see parallel lines like this, you should keep a lookout for corresponding or alternate angles. So here we have a Z shape. This angle here and this angle here are alternate. Because we have parallel lines, alternate angles must be equal. So here and here, it's a Z shape as well that goes like that. This angle here and this angle here are alternate. Because we have parallel lines, they must be equal. Now these two angles are equal because they are vertically opposite. Remember, vertically opposite angles are equal but don't require parallel lines. So each of these triangles here has the same angles, 50, 76, 54. So these two triangles are again acute angled because each of the angles are below 90. They are what we call scalene triangles because they have no equal angles. No equal angles means that the triangles must have no equal sides. So here we've used angle sum of a triangle, corresponding angles, vertically opposite angles, and alternate angles to find unknown angles in a triangle. And this sort of thing is going to be very important when it comes to similar triangles, because you will get two triangles and you'll need to determine whether or not they have the same angles. So using these tools, vertically opposite, alternate, corresponding, angle sum of a triangle, it makes that much easier. It allows you to deduce whether or not two triangles have the same angles. So of course not all triangles are acute angled. They can be right angled or obtuse angled. It depends on the largest angle. So if the largest angle is acute, the triangle is acute angled. If the largest angle is a right angle, it's right angled. And if the largest angle is obtuse angled, this here is obtuse, then the triangle is obtuse angled. So for a right-angled isosceles triangle, it looks like this. Now, for an isosceles triangle, it's always the base angles that are equal. So it's always these two angles. It's where the legs, i.e. the equal sides, meet the non-equal side, the base, where the legs meet the base. So if this angle's 90, these two have to add up to 90, because the angles in a triangle add to 180. So these two add to 90, and they're equal. So they must each be 45 degrees. So in a right-angled isosceles triangle, the angles are always 90, 45, and 45. If you have two equal sides, you must have two equal angles. So for a triangle like this that is obtuse angled, the largest angle is obtuse. So obtuse angled triangles can be isosceles or they can be scalene, depending on how many equal angles and sides that they have. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.